Welcome back, everyone. In today's problem, we are asked to find the values of x and y that satisfy these two equations. Let's solve this step by step. From the first equation, y becomes 6 minus x. When we see y in the second equation, we can replace it with 6 minus x. That gives us x times 6 minus x, and if we simplify this expression, it becomes minus x squared plus 6x at left side. Let's bring all the terms to one side, so the equation becomes this. The equation looks like a standard quadratic equation, where by comparing these two equations, a, b, and c becomes 1 minus 6 and 36. So to solve this, use the general solution of quadratic equation formula. That means this expression. Let's substitute a by 1, b by minus 6, and c by 36 in the solution of quadratic equation. And we get this result. Inside the square root, we have 36 minus 4 times 36, which becomes minus 3 times 36. So the square root can be simplified as a square root of minus 1 times a square root of 3 times a square root of 36. A square root of 36 is 6, and a square root of minus 1 is the imaginary unit denoted by the symbol I. So x becomes 6 plus and minus I as the imaginary unit times 6 times a square root of 3 divided by 2. If we simplify 6 in numerator by 2 in denominator, we get 3 plus and minus I 3 times the square root of 3. Now that we found x, we can find the value of y using this equation. So it becomes 6 minus this term, and if we simplify these, we get for y 3 minus plus I 3 times the square root of 3. So x and y are complex numbers. So our two solutions will be these two. Or when we change plus by minus in x and minus by plus in y value, because each can take two values. And that's it. Even though the discriminant was negative, we could still find the complex solutions for x and y. If you find this helpful, please do not forget to like and subscribe for more step-by-step math tutorials. Thank you for watching.